Hello and welcome to my video on cognitive psychology. As I've said in my other videos, this is mainly targeted towards the AQA A-level, but would be applicable to other A-levels and general interest. Like I've done on the rest then, we'll start with what the specification actually says you need to know. So if we look there, it's the second bullet point down, the cognitive approach. So you need to look at the study of internal mental processes, the role of schema, the use of theoretical and computer models to explain and make inferences about mental processes, and the emergence of cognitive neuroscience. So I'm going to focus mainly on those key terms because that's generally what you're asked questions on, and as well as that some evaluation, some AO3. So getting into it then, the cognitive approach. Okay, so cognitive psychologists, they look at humans in a particular way, and they focus mainly on what they call the internal mental processes. Okay, so what this means is what's basically going on in the brain, in the mind, when we are exhibiting particular behaviours, when we're thinking about things. You've got a list of terms there: thinking, perception, memory, attention, processing, retrieval. So it's basically what's going on in your brain, not necessarily the biological side of that. Although there is certainly there are links, but we'll look more at biopsychology in a further video, and you need to know the biological approach to psychology as well. But when we talk about cognitive psychology, it is these mental processes. So what are you doing when you are thinking? What are you doing when you are trying to remember something or trying to recall something? How are you taking in the world? Where's your attention? Those are the kind of questions that cognitive psychologists are interested in. That's a bit different than the behavioural psychologists. If you've already looked at the behavioural approach, you'll know that they look at our behaviours and say that our behaviours tell us everything really that you need to know about people and that we've learned from the environment. Whereas cognitive, they look at the other way around. They say actually behaviour is a consequence of our thinking. So there's a different viewpoint on how to view humans there. Obviously the behaviourists are saying, well, the behaviour is the most important and almost the thinking comes second, whereas cognitive psychologists, they truly believe it's the thinking first and that produces the behaviour. So interesting different viewpoints to come from there. The next term we need to look at that you might know, recognise from the specification is inference or inferences. So the idea here is obviously we're talking about internal mental processes, so the thinking that's going on. That's obviously not very easy to observe and to measure and to see. There's no way of actually seeing that. And so what we have to do instead of if we compare it to the behaviourist approach, behaviourists can see the behaviours, and so they can make replicable measurements. They can make conclusions based on what they see, whereas the cognitive psychologists haven't got that luxury. So what we have to do as cognitive psychologists instead is produce models and produce theories that would give us a particular result. So a really good example of this, and you'll look at this later on in the specification, one of your other topics is memory. And memory is a very heavily cognitive idea. A good way to explain memory is through the cognitive approach. And so what we do there's an idea in memory that we can hold about 7 bits of information in our short-term memory, 7 plus or minus 2 bits of information. Okay, and that's now kind of a regarded bit of information for short-term memory. Well, how would we know that? How do we know that that's what the process is? How do we know that there's this particular, we can only hold a particular amount of information, there's a small store? Well, how that was done is people were given certain amounts of information to remember, and they had to keep going and recall the information as it was given until they couldn't do it anymore. So Joseph Jacobs did this, a researcher called Miller did this, and after repeated tests, what they found was that the rough average of most people was about 7 bits of information. Some people could quite easily go up to 9, but any more than that, people struggle to recall information. Okay, so we haven't actually seen this store that's actually a physical place in the brain, but the fact that most people could only remember about 7 bits of information means that we can make an inference, we can reach a conclusion that there is a store that only has a limited capacity in short-term memory, and it is about 7 bits of information. So that's what an inference is. It's a conclusion made through theories and testing those theories. Another way that we make these inferences is actually the cognitive approach was quite heavily linked to computers. If you've looked at the origins of psychology, that might have come up then. So it was around the 50s. Computers were becoming more people were kind of used to the terminology, started getting towards home computers, and so cognitive psychologists borrowed basically the terminology used there. So if you think about memory, for example, as I said, memory is a good cognitive thing to look at. Well, we can view human memory a bit like a computer's memory. So you have an input. Okay, your computer input is a keyboard or a microphone. You're putting something into the system. Well, much like humans do. So we have inputs, don't we? And we have 5 inputs. We have our senses. We take information in from the environment via how we sense them, we hear them, we see them, etc. So they both have an input, the cognitive psychologists say. We then have some sort of storage. So you have that input, and in the computer you've typed your information into your word processor and you store that information. You hit save. Well, again, the cognitive psychologist said that, well, that's almost a little bit like what human memory is like. We have these stores that we can store this information short term or long term. We'll come on to schemas in a second. So we have this storage. And then with computers, you have an output, don't you? So you've typed something and you might print it out. So we then, humans, also have an output. So it's either recalling that memory. And again, we might explain an event that we've seen, and that links into eyewitness testimony. Again, another topic that you'll look at in the memory topic. So this term inference has a big role to play in cognitive psychology, mainly because of the fact that obviously we can't necessarily see these thinking processes. We have to make inferences. We come up with hypotheses and theories. We can come up with computer models. And again, in the memory topic, you will actually see models that different researchers have made. Pictorial model, that's quite common in the cognitive approach. These models are made into pictures, and it allows us to kind of visualize these processes that are happening in the mind. So that's the idea of inference. The next part to look at, and I did just mention that, is the idea of schemas. And schemas are kind of known as a framework of information or packets of information. So again, using the computer analogy, they're a bit like your folders on your desktop on your computer. So the idea is that in our minds in our brains we have these schemas. And you develop these as you go through life. So as a child, you'd have very few schemas, but as you experience the world and experience different things, your schemas develop, and you get more and more. And obviously, someone that's maybe an engineer, their schemas will be heavily tailored towards engineering, whereas someone else who's a sportsman, theirs would be more tailored towards sports. We all have, well, most of us have quite similar schemas. So if I said the word summer, your summer schema should then open. And you should be able to recall things that are associated with the summer. Hopefully sun. If you're in Britain, rain. Suntan lotion. Ice creams. All of those would be associated with summer. So that's your summer schema. And these schemas link as well. So if I take your chair schema, if I say the word chair and ask you to describe a chair, hopefully you'll be able to do that. So you might have 4 legs if you think about a traditional chair. You might have your swivel chair in terms of your computer chair, things like that. All of those different sorts of chair would be in your chair schema. But if I then said the word furniture, that should then link to your chair schema as well as your table schema as well as your sofa schema. Incidentally, your sofa schema may actually be in your chair schema as well. So this idea of a schema is these packets of information, and we develop them as we go through life, and they can change. They're not stable, but similar people brought up in similar environments will have similar schemas. Again, as I say, a British person's summer schema should include rain, whereas someone who's maybe, I don't know, in the south of France, their summer schema would be more sun-orientated. Okay, and then the last part that we need to look at, and the key term, again, that was in the specification, is cognitive neuroscience. And so this is the link, and this is really interesting kind of, it's still being developed at the moment, lots of research going into this, but it's basically the link between this cognitive side of things that I've just described to you there, with all the thinking, the memory, attention, all these processes, but linking that to the biological, the neurological side of it. So what neuro is kind of brain, so looking at actually what brain areas are associated with different things. So when you're perceiving information, what areas of your brain is that connected with? And so as I said, this has got quite far-reaching applications potentially. If we find out more about cognitive neuroscience, we could potentially help people with depression or schizophrenia or OCD if we're seeing what areas are maybe lit up when their symptoms are perceived as being worse. We could potentially develop drugs or other treatments to help that. So it's a really interesting area, not just obviously mental health, which tends to be fairly negative, but obviously the positive side of things. So mindfulness, what are people doing when they're relaxed? There's research into kind of optimism and flow and really kind of positive things, and we can look at the brain areas that are associated with that and try and encourage that for living a better life. So cognitive neuroscience is it's the link between the cognitive approach and the biological approach. So it's looking at the biological structures linked to when we're thinking, to when we're perceiving, when attention's happening. Okay, different methods used then involve fMRI, which is functional magnetic resonance imaging, and what that does, a person will go into an fMRI machine, and their brain is scanned, and it scans kind of the blood flow, and so when a particular task is happening, if blood's flowing more to that area, we would say that that area is associated with that particular task, and so that gives us kind of insights into what's happening in the brain. The other one here is a PET scan, which is positron emission tomography, and in this procedure what happens is the patient is injected, it's actually a radioactive chemical, but it doesn't harm you, it's fine, and from that scanners can pick up again certain areas of the brain that are associated with different functions. So as you can see, really kind of cutting edge stuff, and there's going to be a lot more research done into that in the future. Time to look at some evaluations. We've gone through many of the key points, and as I said before, you will need some evaluation for some of the exam questions, obviously known as AO3 points. So we'll start with some strengths. There are a few strengths, which is good, and you'll start noticing with the different approaches, some of these strengths come up time and time again. And that's fine, but you need to make sure obviously you're applying the particular strength to the particular approach. So I've mentioned applications, real-world applications as a strength before in the social learning theory. And again, it is a strength here for the cognitive approach, but you need to say why and how it's a strength for the cognitive approach. So for this specific example, it's treatments to psychopathology. They tend to be cognitive based, so cognitive behavioural therapy is a really well used, it's got some good results therapy in terms of treating mental health disorders, specifically with CBT depression. You'll also look at OCD. Again, this is another crossover with other parts of the course. So when you look at abnormalities and psychopathology, you'll look at different disorders and how they are treated with different methods, and one of the treatments is cognitive treatment. So it aims at changing what they see as incorrect or faulty thinking processes, and obviously if you believe that the disorder is caused by people thinking in the wrong way and you can change that thinking, then there's a chance that you'll be able to treat that disorder, and so you'll see that with OCD. So that's a strength of the approach, that backs up the approach. If people are getting better based on a treatment that is based on the theory, then that suggests the theory is correct, and so that's a really good approach. I've also got here is also used in AI, artificial intelligence. Again, really kind of cutting edge stuff. The cognitive approach is looking at how humans think and processing. Well, if we know more about that, we can potentially replicate that in computers, and that's again another big area of development at the moment that psychologists and lots of people, Apple and Google, are really interested in looking at kind of these thinking processes and can we map that onto computers. So applications, that's one Strength. Another strength is the use of the scientific method. Again, this will come up when you're looking at the memory topic. Lots of lab kind of studies done using the cognitive approach and cognitive theory. So that again backs up the approach, the fact that it's scientific, it's observable, it's replicable, and it's not just subjective opinion. There are potentially objective answers here from the cognitive approach, and again that backs it up. So if you can use those examples, which you will know kind of later on in the course, you can bring that back when answering approaches questions, and that would be a really good thing to do. And finally, I've got here that is less deterministic. If that's in relation, and again this is a really good thing to do with the approaches topics, if you can compare one approach to another, that's a good way of evaluating it. So if we look at the behavioural approach, that's quite deterministic. It says that really your behaviours are going to be determined by your environment. So if you're brought up in an aggressive environment, the behaviourist approach would say you'd be aggressive. Well, the cognitive approach doesn't take that view, obviously, because it's not looking at behaviour as much, it's looking more at thinking. So there's a bit more free will there. It says that you're free to choose your own thoughts. You might look at an aggressive act and think, well, that's not how I want to behave. I want to behave in a different way. So I'm not saying it's not deterministic, but when I mean less deterministic, that's in relation to maybe some of the other approaches. Again, a good thing to do if you're evaluating approaches, evaluate them against other approaches, and the issues and debates come in as well, and we'll talk about that a bit later on: nature versus nurture, free will versus determinism, etc. Okay, there are some issues with the approach, however, and one of those is what's known as machine reductionism, and this suggests that, well, okay, we're looking at thinking, and actually you're looking at models and computer models. Well, actually, should we be doing that if we're looking at humans? And actually, humans obviously act and think and process very differently to computers. And that might be lost a little bit in some of these theories. So if you've got these models, these pictorial models with boxes and things like that, they're not actually in the brain. And so can we actually start describing human thinking using these models that aren't really there? That's the real issue. That's this machine reductionism. So again, if you can use something specific, that's really good. So I've used the example here of forgetting. So memory, as I said a couple of times, quite a cognitive process. If you look at forgetting, people forget all the time, and when you look at the eyewitness testimony topic, people's memories can actually be quite poor and inaccurate. Whereas with a computer, really, if you save a file, it's going to be there, unless there's been some sort of correction, but it doesn't happen that often, whereas humans forget very often. You must have walked into a room to get something and instantly forgot what it was, or be certain distance from your house and then you remembered you've left something at home. Okay, that happens quite often with humans, but less often with computers. So this machine reductionism said, well, we might be reducing, hence the reductionism side of it, reducing human thinking and processes and behaviour down to explainable models that don't represent the processes that are actually happening. So that's the issue there. Okay, the next weakness is the fact that emotion and motivation may be partly ignored in the cognitive approach. The cognitive approach is very good at telling us how something is happening. So I can tell you how, from behavioural models, how someone is remembering a bit of information. But it takes a little bit away from the emotion there. It might be the cognitive approach might be able to tell you how someone is aggressive, or how someone got a mental health problem, but it doesn't necessarily tell you the why, the feelings behind it, what maybe started that process to begin with, and so it's a good descriptive tool, but maybe not kind of explanatory. Okay, and the final point is that obviously we've used the strength that it's good scientific method, good observable, measurable research, but that brings with it an issue in terms of poor external validity. If we're reducing our memory down to 3 boxes, which one of the memory models does, then actually that's a bit artificial, isn't it? It's not actually explaining the situation that's there. And again, a lot of the tests are done in highly controlled lab studies. Well, okay, someone in a lab might be able to recall 7 bits of information, but does that actually happen when they maybe have 2 people talking to them at the same time, their phone's going off, there's TV on in the background? That's not maybe that's not taken account of in the lab, but that's a realistic example. And so we might have a bit of poor external validity here. Some of the findings that we find in cognitive psychology quite clinical and might not actually apply to the real world as it happens. Okay, well, that's a brief overview of the cognitive approach for you, and as I say, lots of these points get reinforced later on in the course. I've already spoken about psychopathology, about the memory topic, so actually it's in your revision when you come back to this, looking at the approaches, that I think you'll really start to understand it. For now, you just need the keywords and some of those evaluative points. Okay, don't forget to subscribe, and until next time, see ya.